Alright, here we go, you crazy pre-calc cats. We are going to do 4.4 graphs of sines and cosines, aka sinusoids. Okay. The sine function. Range from -1 to 1, domain all reals, no asymptotes, it is bounded. Here's the thing you need to know about sine. Sine starts at 0, 0. Okay? That's the only noteworthy thing right here. And then it repeats and it goes between 1. We're going to talk about all that stuff later. Okay? Cosine. Hold on, I think cosine starts at a 0, 1. Because both the graphs, this curve and this curve, are almost exactly the same. It's just where they start. One shifted a little bit from the other one. Okay? Okay. A sinusoid. The sinusoid can be written in the form of f of x equals a times sine times a b times a x plus c plus d, where a, b, c are linear constants and neither b. Okay. Here's what I want you to understand, guys. When you're adding these numbers, our same rules apply. So if you guys write a sine of bx, so write this, what I'm doing right now, plus d, right? C is your phase shift, right? It moves it left or right, just like before. D is your vertical shift. It moves it up and down, just like we've always done before. Okay, there's not anything different than what we've been doing. If it's next to your x, it moves it left or right. If it's outside of it, it moves up or down. Okay. Remember, if c is negative, it moves it to the right. If it's positive, to the left. If d is positive, it goes up. If it's negative, it goes down. Capiche? So this is the noteworthy material from this one. Keep this written at the top of your paper, and we're going to add to it. A is for amplitude. Amplitude is how loud something is. No, I'm just kidding. Amplitude is this. This is my graph of y equals a times sine of x. Start at 0, 0. Up, down, that's 1 period. It means this goes up a and down negative a. Okay. So this length here is your amplitude. This length here is your amplitude. Okay? Let's try this out. Again, examples are noteworthy, guys. So sine starts at the point 0, 0. Okay, and is always going to be wavy. Right? And I'm actually going to put this. Sine repeats every 2 pi. Now, pretty much, you graph the same curve every time if you're just changing the amplitude. But now I'm just going to mark it like this. It's going to go up 3 and down negative 3. Okay? All there is to it. Okay? Let's talk about the period of sine. The period of sine is usually 2 pi. That's how often wave repeats. Okay? You can see we go up, We go through pi, down, hit 2 pi, then we go up, down, then that'd be 4 pi, up, down to 6 pi. So it repeats every 2 pi. Okay? So let's try this beast out. I'm going to use my own graph. Well, let's look at something. The period, again, this goes back to your original. This is for sure noteworthy. So is this. So is this. This is also noteworthy, guys. Your period of a graph, you take 2 pi and you divide it by whatever b is. Okay? And what that means is, I'm graphing sine of 3x, right? Every time, I'm just going to go up, down, and around. Okay? So now, this is my b, right? So my period is going to be pi, or 2 pi, divided by 3. So it's going to repeat every 2 pi over 3. So I go over here, that's usually 2 pi. I'm going to kind of draw some squiggles over here. Now instead of this being 2 pi, this is going to be 2 pi over 3. Okay? And instead of this being pi, it's going to be pi over 3. Because we're dividing that by 3 too. Okay? That's it. That's the big stuff, guys. Okay. So now your frequency, instead of being 2 pi over b, is absolute value of b divided by 2 pi. Okay? So go ahead and add that to your notes. And that's how often the wave passes by in a amount of time. Okay? That's what frequency is. Okay. Quick review, graphs, sinusoids. I got a really odd trivia question for you guys, because every time I say soids. Which famous pizza place had the campaign, "Avoid the Noid, he destroys pizzas"? It used to be one of my favorite commercials. Okay. And here's your phase shift, vertical shift. And that's if we're using this form. This is the one we're more used to, right? I actually like this one better, because it's more of, well, what we've done in the past, okay? Okay, let's do 2 more examples, call it a day. Write the equation for this beast. Okay, first, starts at 0, 0, right? I'm sorry, that looks too much like a face for me not to fill in. Starts at 0, 0. We know it's sine. Okay. Now our amplitude, it goes up 2.5, so it's 2.5. Right? Right. Now, to find our period, well, I mean, we know our period, 6 pi, because it goes up, it goes down, and it hits here, and then it's going to repeat, okay? So our amplitude's 2.5, that equals our A. Our period's 6 over pi. What we need to find is our B, okay, because we're using the old A times sine of B, x, right? Because we aren't shifting it, because we're on our normal x-axis. So find our period. Remember, period is equal to 2 pi divided by b, right? So what we do is we Remember that trick I taught you where you switch those two numbers out? So 2 pi over 6 pi equals b. Okay, pi's cancel. 1/3 equals b. We have our a, we have our b. The graph is 2.5 times sine of 1/3 x. Okay? That's all there's to it. Maybe we'll do a few more of these in class because they're actually pretty quick and easy to make up. And we got one more, we're going to call it good. Last one. Well, let's do a graph of this guy. Graph. Yes. Okay, this one's actually tough. We start with our graph paper, right? And this one I can't start off by drawing sine right away. I have to do some other stuff. First thing I look for is my amplitude. It's going to be 0.1, right? My period is 2 pi divided by b. In this case, b is 5. It's going to be 2 pi over 5. Okay. Now the tough one. This plus pi over here. So tricky, so tricky, tricky, tricky. Okay. Here's what I do. I usually start 0, 0, right? I usually start 0, 0. But I have to shift pi units to the left. So I'm actually going to start at negative pi. Okay? Now, what do I do next? I'm going to plug in my amplitude. 0.1, a negative 0.1. Okay? Okay? So now, what I do is I go, my period is 2 pi over 5, right? So what's negative pi plus 2 pi over 5? Well, it's going to be negative 3 pi over 5. So we're going to do one whole thing, and we're going to get to negative 3 pi over 5. This is a terrible example to start off with, I just realized. Then we're going to go another 2 pi over 5 over. Okay? In fact, I'm kind of redraw this so it makes more sense. I'm going to zoom in on this beast. 0.1 and negative 0.1. Okay. Oops, oops, oops. So again, my period is 2 pi over 5, which means I repeat every 2 pi over 5. So I add these together, and I got negative 3 pi over 5. Okay. Means I go up, down. There we go. Add again. We get pi over 5. Up, down, around. Add it again. 2 pi over 5. Again, that's negative. So we end up over here at pi over 5. This should be going to negative 0.1, by the way. Add again. We have our 3 pi over 5. And so forth, so forth. So that's our graph. That's a really poorly drawn graph. Hopefully it'll do better next time. Enjoy!